we're going to take a look at the homework involved with the isosceles triangle and the converse of the isosceles triangle today. The isosceles triangle theorem states if I have two sides that are the same, indicated by slashes, the angles across from them are going to be the same as well. The converse of the isosceles triangle theorem states if I have two angles that are the same, then the sides across from them are going to be the same as well. And we can use these to our advantage in order to figure out side lengths, angle lengths. For instance, in our first problem, we have four different angles that we have to figure out: angle CAD, angle ACB, angle ACB, and angle ABC. First things first, we might as well start with CAD here. So angle CAD. And in letter B, we are tasked with finding ACD as well. So these are the two angles in our first couple problems. So if I look at the triangle that is comprised of these two angles, it's really triangle ACD here. I know a triangle, all three angles are going to add up to 180 degrees. So fortunately for us, we have one of the angle measurements being 92. Question becomes, what am I supposed to use for up here in these two corners, because we don't really have anything. Fortunately for us, we have a little clue. Here they put two slashes between AD and DC. So this tells me that AD and DC are the same. Again, number of slashes will indicate which sides are the same. So if I look at A to C here, I see I have one slash. C to B has one slash. So because each has one slash, that tells me these two sides are the same. AD having two slashes, DC having two slashes tells me those two sides are the same. And if there were sides that had three slashes, the ones that had three slashes would be the same as well. So here we are told that the two sides are the same. The isosceles triangle theorem states if the sides across, or the angles across from the congruent sides, are going to be the same as well. So if I go across from angle A, I see I hit DC. And if I go across from angle C, I see I hit AD. So these being the same is going to tell me that angle CAD and angle ACD are going to be the same. So I'm going to put a little swoop here. A single swoop means these two angles are going to be the same. I'll use green so that way they can view it. Question becomes, what am I supposed to put in there? We don't know what the angles are. So anytime we have an unknown, we like to use variables. Fortunately for us, because they're the same, I only have to use the same letter. Now in math, the most common letter we use is X. So if angle CAD is X, then ACD is also going to be X. Again, because of the isosceles triangle theorem. Two sides are the same, angles across are going to be the same. So now I have three angles with some sort of marking that I can use in order to figure out what X is. If I were to add up the three angles, I'm going to get 180 degrees. So we have X plus 92 gives me 180. We have 2x plus 92 is 180. If I subtract 92, I get 2x, I'll put it off to the side here, 2x equals 88. I just have to divide by 2, and I'm going to get both A and B. 88 divided by 2 is going to give me 44 degrees. So again, we solve for x. This is a single x, so angle CAD is going to be 44 degrees. And angle ACD is going to be 44 degrees as well. Again, because single x, solve for x. Now the next two, we have to figure out angle ACB, which is this angle down here, and ABC, which is this angle here. Now what I want to do is I need to figure out what we have going on. So now that we know what these angles are, I'm going to erase these. Now I'm going to put the angle measurement here. So we are told this angle up here is 44 degrees. And we know this angle is 44 degrees here at ACD. So ACB, we need to figure out this angle right here. Now, if we think about it, going all the way across, we have a straight line. So from D to C to B, it's a straight shot line. If I know this part here in the corner is 44 degrees, I can use this part here. I can add 44 and the missing piece together and set it equal to the number of degrees in a line. And we learned previously that a line has 180 degrees as well. So if I add up our missing angle here, and I'll use a different letter this time. We used X last time, so we'll use Y here. So if I do 44 plus Y, I'm going to get 180 degrees. I subtract 44, and I get Y equals 136. So angle ACB is going to be 136 degrees. And now I'm going to replace that with 136 degrees. And last but not least, we need to figure out ABC. So this angle right here in the corner, where I drew the blue line, squiggly line there, here we have the two slashes here on AC and on CB. Again, it looks kind of wonky because the slashes are going off towards the same line. Again, it's the angle that's across from it. So if I look at angle C, the side across from angle C is actually the hypotenuse, which is AB. If I were to go across from, if you're unsure where to go, always start at the angle and kind of go through the center. So we go across, and I see I hit CB. At angle B, I start off, I kind of go off towards the middle, and I see I hit AC. So I hit the two sides that are the same. So this tells me this angle here, angle CAB, and angle ABC are the same as well. Again, we don't have any markings in here to help us figure out what it is because I'm missing two things. But if they're the same, I can use the same letter. So previously we used X. Last time we used Y. We'll use Z this time. So here in the corner, we'll say this is Z degrees. And because the two angles are the same, this is also going to be Z degrees. Triangle, if I add up all three angles, I'm going to get 180 degrees. So if I take the 136 degrees that we have for angle ACB, and I add in the Z and the Z, I'm going to get 180. So to simplify, I combine the Z's, 136 plus 2Z gives me 180. I'll subtract 136 from both sides, and I get 2Z is 44. And we'll divide by 2 last. So we get Z is 22 degrees. So now that we know that Z is 22 degrees, this tells me angle ABC is going to be 22 degrees because angle ABC is just marked with that Z. So again, we have two triangles kind of smushed together, a lot of information, a lot of slashes, but we can work our way through it slowly but surely in order to figure out the different values of the angles. And we'll also get problems, for instance, in number 2, find the value of X and Y. We just have to follow directions. So X and Y here we have ML being 2Y plus 6, MP being 4, PL being 5X minus 3, and we are told angle P and angle